Recent advances in projection technology have made it possible to integrate projectors into personal devices such as mobile phones. Personal projection promises new flexibility in the notion of ubiquitous interfaces to simplify the sharing and exchange of information between individuals. Let us consider two users with projector-enabled mobile phones. In order to share data, the users place their displays in a spatially contiguous manner, thus allowing the devices to detect each other and create a shared area where the users can exchange information. By performing gestures in the shared display, users are able to initiate the transfer of objects such as files over a shared communication medium such as Bluetooth or wireless network. Another application is the visualization of large data sets stored in a common server, such as a large map. We can build a large display from several interactive display units, each fetching and displaying only data relevant to its portion of the visualization. Each display unit also handles user gesture input for its portion of the display and informs the others of its input, causing them all to react similarly. Such display-based interaction is made possible through the use of a distributed framework we proposed in 2006 known as plug-and-play projectors, or PPPs. A PPP consists of a camera and a projector, forming a self-sufficient unit. Our earlier work shows that we can place several PPPs together to create a larger display. Using a distributed framework, the configuration of the PPPs can be discovered, and they can be accurately registered if necessary. We now show how we use two such PPPs as interactive displays that allow data transfer between devices. Each PPP can detect gestures on its display using its camera and broadcast the gesture parameters and associated data to the other PPP. The PPP's camera also allows us to capture and transfer new images between devices. We can even delete data from either of the devices. Here we can see the state of the file system of both devices before and after all user input has been processed. Notice that files have been moved, deleted, and even created through camera capture. In this demonstration, we assemble 4 PPPs in a rear projection tile display. In order to sense gestures through the screen after registration has occurred, we use infrared illuminators and infrared cameras on each of the PPPs. Each PPP can detect gestures in its display area and broadcast the gesture parameters to all other PPPs in the display. Here we have disabled the visualization component of one of the PPPs. We can see that the PPP's camera captures gestures and the other PPPs are receiving its gesture parameters and acting accordingly. We demonstrate this concept with 2 gestures. One to move the map using an open palm, and another to zoom in and out using the rotation of a closed palm. Notice that each PPP only fetches and displays data relevant to its portion of the display, and must fetch additional data when the map pans and zooms. Thus we have shown how we can use projector camera systems to create displays that can transfer data across multiple loosely connected devices triggered by a distributed method to handle human interaction.